Hey June, the prime factorization of 30 is 2 times 3 times 5. So, what would be the prime factorization of negative 30? Normally, prime factorization is discussed only for positive integers. All natural numbers can be written as a product of prime numbers. This representation is unique. It's known as the Fundamental Theorem of Arithmetic. On the other hand, negative integers are normally excluded from the definition of primes and composites. So, if we want a prime factorization of negative 30, we first need to bring negative integers into the world of primes and composites. A prime number is a natural number whose only divisors are 1 and itself. So, what about negative 2? Negative 2 can be written as 1 times negative 2. Since this negative 2 is negative 2 itself, it might seem to fit the definition of a prime number. But in practice, we usually don't call them primes. Why is that? If we allowed negative primes without any restriction, the same number could have several different factorizations. For example, 30. It could also be written as negative 2 times negative 3 times 5, or negative 2 times 3 times negative 5. The fundamental theorem of arithmetic breaks down. We lose one of the basic rules that arithmetic depends on. However, if we define primes a bit more carefully, we can actually include negative integers as well. In prime factorization, we write negative 2 as negative 1 times 2, not as 1 times negative 2. Every negative integer can be separated into negative 1 times a positive integer. Under this idea, if that positive part is a prime, we can also regard the negative integer as a prime. Under this extended definition, negative 2 and negative 3 become primes, while numbers like negative 10 or negative 12 remain composites. Now, a prime number is an integer whose only divisors are plus or minus 1 and itself. The usual primes and their negative counterparts are all primes as well. Then, what happens to the fundamental theorem of arithmetic? The factorization of 30 still remains the same, 2 times 3 times 5. The prime factorization of negative 30 becomes negative 1 times 2 times 3 times 5. This representation is still unique. Extending primes to include negative integers does not violate the fundamental theorem of arithmetic. So, what do you think? Would you accept this extended definition of prime numbers?